In the Canadian Electrical Code, CEC, as adopted in Ontario via the Ontario Electrical Safety Code, OESC, there is no absolute minimum conductor size, such as a fixed AWG, like number 14 or number 12, specified for transformers secondary conductors in general. Conductor sizing is based on ampacity requirements, per Rule 26 to 258 1 and 2 in recent editions, for example, 2021-2024. Primary and secondary conductors must have an allowable ampacity of not less than 125% of the transformer S-rated primary-secondary current full load current. This is cross-referenced with Section 14 rules, for example, 14 to 104 taps, 14 to 104 conductor protection via overcurrent devices, and Table 13 allowances. Ampacity comes from table to copper, 75 degrees Celsius column, typical for most terminations or other applicable tables. For very small transformers, for example, control transformers, small dry-type units, or low kVA distribution transformers, the calculated 125% rated secondary current can be low, leading to small conductor sizes. However, practical and safety considerations often lead to a de facto minimum in many jurisdictions and exam contexts. Why number 6 AWG? Copper is the answer in this context. For small transformers where primary overcurrent protection is 15A, the smallest standard branch circuit breaker size, the secondary current depending on voltage ratio might be low, but the code and inspection practice often require secondary conductors to be sized to handle at least the equivalent of a 15, a primary fault scenario, or to meet minimum mechanical termination requirements. In Ontario, CEC training materials, certification exams, common interpretations, including ESA guidance in some cases, the minimum size for transformer secondary conductors copper is frequently cited as #6AWG, when no smaller size is justified by calculation or when using tap rules, short runs. Smaller sizes, like number 8, number 12, or number 14, are permitted by ampacity alone for very low current transformers, but they are not the standard minimum in practice for secondary conductors feeding panels or loads due to voltage drop, mechanical strength termination, torque, and avoiding overload risks if primary protection doesn't fully limit secondary faults. Number 14 or number 12 would be too small for most transformer secondaries. Even small ones often require larger for 125% rating or protection equivalence, while number 8 is sometimes allowed but not the conservative minimum. Quick comparison of options: copper, 75 degrees Celsius ampacity from Table 2, number 14, 20A too small for anything beyond tiny controlled transformers, 12 is 5, a common for lighting general branch, but not typical minimum for transformer secondaries. Number 8, 50A, possible for small transformers, but not the standard minimum cited. #665A, aligns with the practical exam minimum for copper secondary conductors in many CEC Ontario contexts, especially when primary is protected at low standard sizes. For example, 15 to 30A and secondary needs to handle inrush or fault without undersizing. If the question assumes a typical dry-type distribution transformer, even small kVA, or follows common exam phrasing for minimum size without specifying kVA voltage, number 6 is the expected choice. Always size per actual rated current times 1.25 and verify with the latest OESC edition, as no fixed one-size-fits-all minimum exists in the literal code text, but number 6 is the safe, commonly enforced floor for copper